Welcome back. So next up on stage, we have Sebastian Meyer. He is talking about a scalable systems management solution for data centers based on SaltStack. So lean back, relax, and enjoy the talk.
Hello and welcome. Is it okay? Test. Yeah, seems okay. Yeah, I want to present a small introduction into Salt and how to do things with Salt, how to build a reactive environment you could use in your data centers to just improve things and automate everything that can be automated. So I work for B1 Systems. We are doing consulting and trainings and support for all kinds of Linux and open source stuff. Don't know who of you have heard about us. And yeah, basically operating systems, systems management, configuration management, the cloud stuff, virtualization, whatever there is, we probably do it if you ask nicely. So now to Salt. What is Salt? Is it just another systems management solution, or what does it do? Well, it takes inspiration from other configuration and systems management systems like Puppet, Ansible, or Chef. Who of you has worked with SaltStack already? One? Okay. And with some of the other, Puppet, Chef? Probably nearly everyone. Okay. So you'll see that Salt reuses a lot of things you've seen in Puppet or some of the things you've seen in Ansible, and just does a small spin on it. But in the end, it's a lot of the same paradigms you can use with Puppet, you can also use with Salt here. Salt focuses on the full system lifecycle, so you can deploy your machines with Salt from you have nothing or just a hypervisor, deploy your machines, and then deploy your configuration and applications on it. And in the end, if you don't want to have it anymore, you can also destroy the machine automatically via SaltStack. So you can do all things with your systems. It's relatively easily to scale to up to a few thousand systems. So I've seen environments up to 4,000 systems without much ado about them, just normal Salt stuff you get with the installer, and you don't have to build in a lot of tools as you would have to do with Puppet to easily scale it. Well, since it uses YAML and Jinja, it's easy to learn. YAML, you all know probably of Hyra or something like Ansible, and Ansible also uses Jinja too as its templating engine, but you can also just write Python code and use that to define your states in SaltStack. So SaltStack does configuration management, systems management, and remote execution. That's the bit here that's a bit different than in Puppet, for example. Here you have inbuilt execution modules you can use to deploy some actions on your systems, not just a command module which lets you run arbitrary commands, but also already inbuilt stuff you could find useful for your systems. So the basic concept is you have a master server and your minions. And on the master, you save your configuration, and from the master, then you send commands or say, hey, get your configuration and apply it. And then the minions apply that stuff and send back the result. So business as usual. Communication is fully encrypted via AES. And so you also have to accept the keys here like you would do on Puppet. Then you can scale SaltStack. You have the possibility to use so-called syndic systems, which are submasters of the global Salt master, and they each can manage their own systems, but they get their configuration from the Salt master. So you have one master of masters, and however many syndic nodes you want, and then your clients can register to those syndic nodes to get the load of the master. That's all that you need basically to do to scale out SaltStack. If you want to achieve high availability or just want a bit more flexibility, you can use multiple masters. You can set that up as active-active, where you have all the keys on all servers and all the configuration on all servers mirrored, and then your minions can connect to each of the master servers or syndic servers and get their configuration. That's also a bit that you can do to load balance your stuff. And you can set up the whole thing as failover. So you can say, hey, minions, please go to this master, and if it's not available, go to the other one. Then that's not that complicated to set up. It's basically just keep everything in sync between the masters, which is easy to do with Git repository or something like that. So we have basically 4 possibilities we can achieve our state definition with Salt. Our minions can pull from the master. That's the thing we do with Puppet all the time, where the agent runs, gets the configuration. The same thing we can do with Salt, where the minions just grab their configuration and apply it locally. Then we can do it the other way around. The master goes to the minions and says, hey, please apply those states or your state configuration, and then they'll get, they do that, and everything's happy. Everyone is happy. If you want to set up SaltStack masterless, you can do that too. You can just apply your configuration locally and check out the configuration files and variable files from a Git repository or something like that, and just do it on the minions without any master. That's obviously a lot better scalable than everything else, but it's a bit more to do here. So you would have to configure it on every minion, and you don't have a central node where you can just grab all the reports or something like that. And we have a mode here which allows us to deploy our configuration over SSH. So the master connects per SSH to the minions and deploys a salt binary, which then does all the magic locally on the systems. That's a bit like Ansible here, yeah? Yeah, so in the second mode here, the master pushes to the minions. You have still the agent on the minions. The master would create an event for the minions to please apply your state, and then the minions would call or get that state from the master. Any other questions up to here? Okay. So with that, with those 4 states, let's have a look at the remote execution system. It's called remote execution system, but basically you can also run those commands locally on the minion. You just won't do anything with the results then. The basic call you use with Salt is Salt, then the target, which can be either just normal globbing on the name, where you have specify part of the name and put an asterisk in, or you can target with facts or something like that, whatever you want. And then you have a module and a function. Salt has a lot of execution modules which interface to different systems, platforms. You have an Apache, disk, whatever you want. And those have all functions that you can use to get information of your systems or do something there. For example, disk.percent just checks the argument for how much space is occupied on that partition. In this instance, that would be, okay, check the SRV partition if there how many space there's left or how many space there's occupied. If you want to target with facts, you'll have to collect them from the minions, of course. Here, those facts are called grains. Grains are basically just static information about your systems, like, okay, which OS is on there, which MAC addresses do we have, which IP. It gets pulled in some regular intervals, but it's not that it's up to date all the time. So it doesn't collect that information each run, but rather once and then a week later or so again. And you can use this data to target your minions or do some basic flow control in your states or variables. Now, most things you do with Salt will be configuration management, like you would do with Puppet. And configuration management is done in states files. State files have a basic YAML syntax. You have your ID, then the module and the function you want to use, a name, and arguments for that function. You can have multiple functions with the same ID, but they have to be from different modules. So I can have the single ID controlling a package, a service, and something else, but I cannot specify two different package functions on the same ID. And if I have my states ready, then I want to say someplace, okay, these states get applied to these minions. This is done in the so-called top file. The top file is same syntax as the states. Basically, it's just YAML. Then you have your environment base in this case. You're targeting this asterisk here or the LAN and DMZ here. And then you list all the states you want to apply. For example, in this case, okay, all my systems get the monitoring, SSH, and syslog configuration. And all my LAN systems get some NTP LAN configuration, and all my DMZ systems get the DMZ NTP configuration and a firewall. That's basically the same like you do in a site PP and Puppet. You can also specify that in external software. For example, you can use Foreman to do that as well, like we would do with Puppet. And the difference here is that in Salt, those things get merged. So where in Puppet you have, okay, I check for the first IMatch and do exactly that. Here you check everything in that file if the minion matches this. And if it matches, it gets all the states in there. So you've written your states. You want to apply them to your host. Everything's fine. But now you need some variables. For example, you want to use different NTP servers, or you want, basically just any configuration you want to do dynamically. You want to use variables. For that, you can use so-called pillar data. Pillar data is just YAML files again, where you store your variables, and that's a small example with some Jinja logic in it. What it does here is specifies a dictionary called NTP, and in that it sets two values, NTP service and common. And those values get set based on what the name of the minion is. So it checks the grains, the facts we get from our systems, for the system ID. System ID is usually the FQDN of the system. And if that starts with my NTP server in this case, then we use the upstream pool NTP servers. And for our other systems, we want to use our internal NTP servers. So that would be one possible way to set up all your NTP servers with the same state file, but different parameters here, where you just set different variables based on host names, or you could set those based on OS or whatever you want. And then you have, for the pillar 2, a top file, where you can specify, okay, those servers get those variable files, and those servers get these others. And basically what you want to do is to name them the same as the state files you have. So I have my states, monitoring, SSH, syslog, NTP, and firewall. And on the pillar side, I have monitoring, SSH, syslog. It's exactly the same for all my systems. But then I want a different NTP config for my LAN and DMZ servers. So I have a pillar file for my LAN servers and a pillar file for my DMZ servers, and define the same variables in those, but one part of my servers gets the one file and the other part gets the other file, and my DMZ servers get my firewall configuration as well. Simple as that. You don't have to call the state files in the pillar and the states the same, but it's advised because then you exactly know, okay, this is for that, and you don't get confused that easily. You can also use external pillar. You could use Hyra, or you could use as well Foreman again, something, whatever. There are a lot of different modules for external pillars. So you can use Cobbler, for example. You have a lot of choices here again. And if you have defined all this, so your state files, your top state file, which says, okay, these machines get those configuration files and those. Then you have to get your configuration out to your minions. You can do that with the salt command and the state.highstate function. The state.highstate function basically just goes to the top file, sees, okay, I match all these different states and applies those states. So it's basically a Puppet apply for everything. I can also do a state.sls. This is used to apply a single state to my system. So for example, if I have written a new state and I want to test it on one of my systems, I can just go and say, okay, please execute this state. Then it would just execute this state file, but get, again, all my pillar data. Because there I can set different variables, and I don't have to name them the same. If I want to do the other way around, call that stuff from the minion, then I would use salt call to just execute the same functions. So in this case, the minion would just go to the master, say, please give me my state, and I want to execute it. If you want to reuse your code, which basically you want to do, or want to reuse code other people have written, there's the so-called formulas, which are basically the same as Ansible roles or Puppet modules. It's a collection of files and states which apply to a system and configure it the way you want. Formulas are usually parameterized so that you can specify your variables in the pillar data, and then you get the information, okay, for these systems you want those variables. There's an official GitHub organization for SaltStack formulas called SaltStack formulas, and those are kind of official. Basically, someone has written a formula, says, hey, I want to share it, please, could you fork it into your repository, and then they do it, and everything is well. There are not that many formulas out there yet, so nowhere near the amount of Puppet modules you could use, or Salt roads, Ansible roads, but they're getting there slowly. Those formulas you can use directly from a version control system, Git, SVN, probably whatever you want. Or you can make a local copy of that and then include it from there. You have to put the new formula into your master configuration as a new root where it looks for states. So every time you want to use a new formula that's not written by yourself, you have the problem that you have to stop the master and start it again. I don't know why they chose that way to do it, but that's sadly the way it is, and there's no way around it for now. The formula is configurable via pillar data, and the mapping there is done via a Jinja map. So you have a map file which defines the default values in the formula, pulls out every variable matching from pillar, and then merges those together. That pillar values override the values in the Jinja file. That way, you should be able to deploy any formula without further configuration, but you can configure it if you want. And you can also use those existing formulas to include them in your own states. So I can say, please include me the Apache formula and put those vhosts to that too. And then please require or watch those vhost files in my Apache service defined in the formula. So I can put requirements across formulas, and I can extend them rather easily without having to change the original formula. Now, I've prepared a small demo to show you how it looks like on my system. Can everyone read that? Is that big enough? I'll take that as a yes. So on the left side is my Salt master. And what I will do here is I will just, for a moment, show you the configuration I've done. I have in here LXC configuration, my Salt Minion state and UFV state, and my top file. And my top file, excuse me, I just have defined, okay, all my minions get my NTP configuration and my Salt Minion configuration. Everything that's Ubuntu also gets the UFV, which just disables the service because I hate dealing with firewalls here. On my Salt Minion 2, I will deploy an NTP server. On my Salt Minion 3, I will deploy some LXC stuff. And on my Salt Minion 5, we'll come to that later, I will deploy a web application. So now if I look at this top file, you see there are a lot of states mentioned that aren't in this directory where everything else is. So SRV Salt is basically the default directory where you put your states, but you can extend that, and if you want to use formulas, it's best practice to just add another formulas directory, and in there are the formulas I use from upstream. So here we have my NTP configuration, and the stuff for my web app I will use to deploy a small WordPress instance, yeah? Yes, that's what you see here. This environment is all base. So you can have a development environment or something else, and you just specify a different source for that environment. Could be just a different directory or a different Git branch, for example. Though we don't have something like R10K yet, which does that automatically for us. Maybe we'll come to that. And when I now apply both states, I want to set some variables. I defined that in the pillar directory, which has basically variables for my NTP configuration, MySQL, and WordPress. And if I look here, I have all my servers get the NTP configuration, And the Salt Minion also gets the NTP server configuration, with the Salt Minion 5 getting WordPress and MySQL variables. The notation is rather easy. If you just want to use a file called ntp.sls, then you could use just NTP. If you want to have multiple files in the same namespace, you would make a directory, put an init.sls into that. That's your normal, that you can call with the directory name, and every other file in there you would call with this dot notation. So in my NTP directory, I have a file init.sls, and I should have a file server.sls, but that would explain why that state always fails. Whatever. Now I want to apply my high state on that minion. Well, I can't because I don't have accepted this key yet. We have here the salt key commando, and we could define an auto-sign map where I put my systems in that will be auto-signed, or I can just auto-sign all systems. Or I just use the salt key commando and accept all those keys. And then I should be able to execute the salt high state for that minion. This takes some time. It's not as an Ansible where you get status updates after each task, but something's broken here. Yay. Let's check for number 3. Well, let's see if it works. If not, we'll learn something. Now, in the meantime, you get reports. After you deployed your state on the files, you get an answer, okay, that's what I've done, and those things were okay, those things I had to change, and those things I couldn't change. You don't want to put them all on the master. You can't do anything with them there, so what you can use are so-called returners. Returners are a mechanism to tell the minion, please don't send your data only to me, but only send it there. For example, Redis or a MongoDB, any SQL database, whatever you want, basically. It's just a Python script which takes the data and puts it wherever you want it. There's also a syslog returner, so we could see on the syslog, okay, what happened to our systems. See, well, it takes a long time, but it didn't work as well. Cool. Let's delete all those keys. Restart the minion, and accept it again. And now let's see if it works. Well, that looks better. So what happened here? It got its state. The package NTP is installed. NTP service is not running because the file's not there, and I missed putting in a requisite there, require this config file. But the salt minion is installed, the salt repository is there. There are additionally packages installed, and the salt minion is running. But it couldn't install LXC packages. Well, why not? Let's see again. Something blocks my DP. So, but now my NTP conf is there, and my service is running. So it works, kinda. Not sure why. Good thing it worked yesterday. Whatever. Now, that's basic configuration management. You can do that with Puppet as well. No need to use Salt, right? But Salt has a thing called event-driven infrastructure. Whenever you do something with Salt, it triggers an event. So you schedule an action, you get an event. The minions return that action, you get another event for each minion. And you can also define events yourself. And those events all go over 0MQ. And then you have on the Salt master the possibility to define Salt-called reactors, which are basically just executables run whenever a specific event occurs. So the master does something on the minion, and the minion returns its results or whatever, and events are created. For example, this Salt dispersion function, which gets the result 11%. Those are 3 different events. The first event is, okay, here something happened. That's relatively trivial and uninteresting, and that's why I put it out there. And the next is, okay, here's a new job for you. And in the job, there is the function, which should be called, which minions should execute that function, and what target was specified. So in this case, I specified Salt minion 01. If I would have specified Salt minion minus star, then I would get all my Salt minions in this list, and here the star one. And after my minions finish, I get a return from every Salt minion. It's located directly under the job. So I have here the new job, Salt job, timestamp new, and then Salt job, timestamp return. And I can listen for those events and just execute whatever I want. I'll come to that later. In the return, I have a lot of data which I can use to check in the returner and do something about that. If I want to execute my high state, I have the problem, okay, I get an event when I schedule the high state, and then I get an event when everyone's finished, or for each minion that has finished the high state. But now I want to have an event in the middle of my state. For example, okay, I'm ready, I finished setting up the Apache web server, you can now put me into the load balancer pool, for example. Then I can just put an event into my state, say, okay, right now I'm finished with all web server configuration, you can now put me into that pool for the load balancer. Then I just send an event from my state and listen to it on the master and set up a reactor. Another case where I want to create events are beacons. Beacons are a feature which hooks into system processes, like I notify, which check the load in intervals, or something like that. And based on that, it creates events. So I can say, oh, I want an event if that disk is 80% full. Or I want an event if my load is 90% on all cores, or something like that. Or if I have a special message in my journal. An easy example would be iNotify, where I can just say, okay, here, if someone changes my etc mod d, please do something about it. This is the beacon, and this sends an event. Okay, here, new beacon event, someone modified my etc mod d. And then I have my reactors, which basically just listen on that event bus and get called if they match that event via a glob. I define them on the master, and I just put it again in a Python dictionary, or Python list in this case, and list all those things that should be done. For example, if a Salt minion starts up and connects to the master, then there is a Salt minion start event. The star here stands for every minion because those get sorted by minion. And then I can say, okay, if if a minion starts, please execute that SRV reactor SLS file, start SLS file. Or if something should react to my event I defined in my state, then please execute that status SLS file. And another demo for that. Oh, now it works perfectly. So what this did is basically just install a bunch of packages for LXC. And I defined 3, and it installed all the other stuff it needed for that. That's great because we need that later. And now I hope Salt Minion 5 works as well. Salt key minus. So now I accepted the single key, not all of them, and I should be able to just say salt minion 5. I have tab completion here, so I don't need to put it all the way out there. And if that works, I should have a working WordPress deployment afterwards. We'll see. Now for my beacon, I have defined a beacon file, which basically tells the minion if I changed, okay, of course it didn't work, if I change the etc_mod_d, then please call that reactor. It looks like this in the Salt master configuration. Please call a reactor on the beacon event I notify, and please execute mail SLS. Normally, what it should do is just execute, okay, here is my mail, but since on Ubuntu mail isn't installed, I just create a file called new mail in the root home directory. I have my beacon configuration on the minion, not on the master. And that basically just says, okay, here define my iNotify beacon. Whenever etc_mod_d is modified, fire an event. So let's create that file. Nothing should happen. And if I change it, I now have a file new mail in my directory, which says, oh, etc_mod_d changed. Great. I'm not sure why it does say that twice, probably because there are multiple minions running by now, because I fucked up something in the setup. So if I do that again, I get new entries. They shouldn't be double, that's my fault. So what's done is, on the master, it executes the following file. Again, I have an ID, send new mail, and run a local command on the target machine. So I say, okay, please target the machine from which the event comes, which is stored in the data dictionary. And then please just echo the date and which file has changed into root new mail. You could also set there a mail command or execute it on the master if you want, or do everything else. You can use all execution modules that are in Salt, so you can, really do commands, check something else, put it in a load balancer pool, whatever you want. You could also, oh, my disk is 80% full, please resize it to a larger size. Works without problems. Let's see what failed here. Package installed. Couldn't install the packages because I don't know. Let's try again. So we'll see if that works. As I already said, we have use cases load balancing. We can do job automation, like resize my disk if it's getting full, or just send an alert to me with a mail. You have a small monitoring feature with the beacons, and you can do really powerful things with it if you think about it. And the last part I want to tell you about Salt is Salt Cloud. Salt Cloud is an interface to basically every public or private cloud you can think of. And it uses their APIs to do stuff on them. So deploy machines and destroy machines. Define them with a profile and then check, okay, which states should be applied to them and apply those states. So you could define your whole infrastructure within Salt. Say, okay, my whole infrastructure runs on OpenStack now, but now I want it to run on something else, and just bring it over there by changing the provider you use. And it should work out of the box. First, you have to define a so-called provider, which in this case is EC2. You could also have OpenStack, Google Cloud Engine, Azure, DigitalOcean. Oh, there are multiple options there for you. I have an example with LXC. We'll get to that. And there you specify which driver should be used, so which service is it, and your credentials you want to use to access that service, and which Minion options you want to set for the Minions installed on those systems. For example, here you can set the master server, which those Minions should connect to. After you defined your provider, you need to profile using that provider. A profile is basically a definition of your system afterwards, where it tells you, okay, use this provider with this image or template, and some other options for the instance, and you can define more Minion options. So I could say for LXC, please use my LXC provider I defined before, and create a new machine based on Ubuntu Trusty, and set the password to test123. And that's called my fancy profile. Now you can go and say, okay, please Salt Cloud deploy me a machine with that profile manually. That works, but you don't want to do that for larger environments. What you can do now is you specify a map file where you have your profile, list your instances below that, and then you can set some other options and say, okay, please Salt, execute that map file and do everything what's in there and define those machines. So in this case, it would define instance 1 and 2 with the profile 1, and instances 3 and 4 with profile 2. Could be different providers, could be everything. That's all defined in the profiles. It just would deploy these machines. I can also tell him to destroy all those machines in there, or destroy all other machines deployed on that provider accessible with my keys, if I want that. So that's where the whole lifecycle management comes into play, where I can deploy machines, destroy machines, and put configuration on them. I could also bootstrap a completely new Salt environment, where I define my instances and tell the first instance to be a new salt master. And then on the other instances, I would say, okay, this is your master now. So I could create a capsuled environment, basically. And as a last step, if you have probably thousands of existing machines, how do you get salt onto all of them? You could use salt SSH. You could use SSH and just execute a script. Or you can use the saltify driver, which basically gives you the possibility to define a profile where you specify your SSH username and the key file that should be used to log in on that machine. And then you can define in a map file, okay, this machine is that host, please saltify it. Those machines will get the name that is specified here. And Salt connects to the IP, says, okay, please let me check. I will install Salt now. It does that using the Salt bootstrap script. The Salt bootstrap script is transferred from the master to the Minion. And then on that Minion, it's executed, looks for local repositories. If they are there and the packages are available, it will just install them from the repositories. Otherwise, it will add the repositories from upstream and install it from there. So, and before I end my presentation, okay, the WordPress example didn't work, why ever? But I have prepared an LXC example. So I have here no LXC machines running. I have defined my LXC provider in my providers directory. Basically just tells me, okay, on Salt Minion 3, use LXC as provider. That's all that's needed for that. Then I have a LXC profile. That tells Salt to use this provider and put template Ubuntu on there, release trusty, and sets the master options for the Minion, and sets the password test123. And now I have a cloud map file, which just says, okay, roll this profile out for those 3 minions. And what it will do is it will create those instances on Salt Minion 3. Salt cloud -m and etc salt. You should be able to tap that as well, but I couldn't get it to work. What you want to do if you specify multiple instances in your map file, you want to run it with -large p, because then it will do all the work in parallel. So what it did now is it logged in on the Minion, checked if there are any existing LXC containers. And if one of those containers already had existed, it wouldn't have created it, but they didn't. So now I tell them, okay, please create those containers. And now we see on that Salt Minion, we have LXC Minion 1, 2, and 3. And they are based on Ubuntu Trusty template. And it will take a while now, because now Salt is using that Salt bootstrap script to register those systems to my master. So they will download the necessary Salt packages and then connect to my master. What it also does is it precedes their keys. So they usually, when you start Salt Minion and there is no key on the system, it will create one. But in this case, this key will be created on the master and copied over to the client system, so I don't have to accept them on the master anymore, because I just created them, and that's what that shouldn't require any more work. So while that takes a while, do you have any questions? Yeah?
When you had some packages installed earlier,
Mhm.
there was lots and lots of output of all the dependencies that were pulled in.
Yeah.
So do you have to look through these, or can you configure things so that those are hidden?
Hidden how?
So that
So,
they won't even show in the output.
so you mean if it, so it just shows me if it changes those 3 packages, but not the dependencies. I'm actually not sure if it's possible to do that. I've never seen it before, but I think it's not possible because it always tells you what it changed on the system. So it installed those packages, so that is a change, and it tells you about it. The question was, how can you create custom grains? You can define them on the Minion. It's basically just another option in the Minion configuration, or you can put a grains file there to put them on the Minion. Or what else? Another possibility, if you run, for example, with the cloud map, you can define them when you specify those there. So I think there was an example somewhere here. Oh yeah, here. So in your cloud map, you could say, okay, please define my grain, my key, my value on that system.
Is there a mechanism for Salt to have implicit beacons? So for instance, if I'm defining a file or multiple files that I notify events?
No, that's not, there is no mechanism to do that automatically. You would have to define them by yourself. Because you asked that, you have to be careful, because if you have an iNotify event on changing a file, and you want to say, okay, if that file gets changed manually, please just redeploy my old file. For example, my etc mod d should never change, so instead of sending an email, I would just redeploy the etc mod d from my master. What happens? You create a new event because you're again modifying that file. And then you have to specify in your beacon that please don't fire an event if a state run is running right now. So that's just another hiccup you could run into there. Any other questions? So the download should take a while or shouldn't. Oh. It worked or not. Oh. Basically, what we do is we tell them to get comfortable with the command line interface first. So let's see, okay, does it work everywhere? If they all already have Foreman experience, then we tell them, okay, yeah, sure, you can use that. We integrate that. Or if they already run SUSE Manager, for example, that integrates in a new version also with SaltStack-master, then they could use that, but usually we tell them, okay, just first start with the normal stuff, and then you can think about adding a graphical interface to it or something. Yeah, so the question was if there is a possibility to do some finer-grained debugging like in Ansible, where you get a return for each task. So as of now, you can't do that easily on a master. You have the possibility to change the output level of the master to debug. I'll just do that here. I hope it works. Salt debug, or there are multiple levels you can specify here. It's basically just a log level. So Minion 1, I think that one worked, or three worked in each case. And well, you get some information, what's happening on the master, but you don't get information from the client. When what you have to do basically is check on the client in the log file there. And basically here you get your information if there are errors or something else happened. But there's no possibility as of now to get your information for each state. What you could do is basically you could fire events after each state is run, but that's manual debugging you have to do, not something that's built in. Well, then, thank you, and I hope you find Salt interesting and consider using it.